Good morning, everybody. This is Don Going, CEO of Vertex Consulting. I appreciate you joining us today. We have some excellent content for you focused on kind of the modern cybersecurity landscape and really focused on the concept and the technology of zero trust, what zero trust is about, and also understanding more clearly how we've got to be projecting power into our security environment through threat hunting. And we've also got to be kind of eliminating artificial noise and sort of automating things to make our lives easier so we don't just get inundated with a flood of alerts. And the way we do that is through security automation. So I'm really pleased and excited to have a guest speaker today in Rui Lopes. Rui and I have talked several times about cybersecurity. It's clear to me he is a guru on these things. He's a cybersecurity industry veteran. He's also a certified ethical hacker. He's been in the industry, in cybersecurity specifically, for over 16 years. 10 of those years was with Panda Security in Europe, and Panda was acquired by WatchGuard, and now he's been at WatchGuard approaching 2 years, where his job title is the Senior Technical Evangelist for WatchGuard Technologies. We're trying to not make this a sales pitch at all, but more of an interactive process to discuss what the concepts are about zero trust, how it could be implemented, what the benefits are, and what the protection it affords is, and also talk about how threat hunting is accomplished, what is it really, and how security automation can make our lives a little bit easier. So that said, Rui, I'll turn it over to you. Thanks for joining us, and the floor is yours.
Thanks, Don, and thanks for having me. So our agenda for today, we'll start with having an overview about some relevant stats relevant to not only the landscape that we're addressing, but also the problems and the challenges we're trying to address and solve related with threats, our favorite reference, and I mean the industry's favorite reference to ransomware, some stats on alert fatigue and complexity that are the main topics and the main challenges that we address overall within our unified security platform, and specifically at the endpoint layer. And as a consequence of the status, so to speak, that we'll be looking at, we are going to start a sort of blue-red pill moment with posing the questions about why is endpoint security still struggling with ransomware. We hear it in the news every day, or at least every week, from organizations that clearly have or should have at least some sort of endpoint security strategy, but for sure have some sort of endpoint security product or a combination of product and service deployed. So why are these companies and thus these solutions or these strategies still struggling with the problem of ransomware? And then we will drill down to our specific approach, or our sort of migration from three main pitfalls that we believe introduce and still tie us from a perspective where we at the endpoint are still very trusting. We're still trusting everyone unless there's some suspicion, and migrating that to the possibility of implementing a trust no one, zero trust posture at the endpoint, but making it manageable, because that's the key factor. We're going to pivot this possibility, implementing endpoint security with zero trust, around two main services that we're going to look at. The zero trust application service, which in essence is our answer to file-based malware by essentially controlling the unknown, that is the execution or the possibility to execute yet unknown, unclassified binaries in a protected environment, applications, programs, or components of programs that have never seen before. And on the other hand, we are going to need, in environments that we protect and only allow goodware to run, we are going to have to address the fileless, the malwareless, the living off the land vector. And for that, we need threat hunting. Threat hunting is our answer to the weaponization of goodware in environments that we clean as far as execution of goodware and that we need to protect. At any moment, there's a possibility of weaponization of a goodware application by a malicious actor or in a malicious plot, so to speak. So we need these two sides to the equation, the file vector and that everything else that threat hunting represents, and they come together in the agent that we deploy to the endpoint, in the services that pivot the endpoint security delivery. And I'm going to be able to show you how all of this comes together in our EPDR product, our Endpoint Protection and Detection Response, our STAR product, which is a combination of next generation antivirus and endpoint detection and response pivoted on the zero trust and the threat hunting services. So stats, I mentioned it's our favorite topic. It's the industry's favorite topic, but it is very representative. 590 million was the total value of suspicious activity reported in ransomware related transactions just during the first 6 months of 2021. That represents a 42% increase, in the first quarter or first half of 2021 exceeded the total value reported for the entirety of last year. The numbers for ransoms paid since 2019 in Bitcoin alone are astronomical. And there's a stat that I particularly like to highlight about 70% of the ransomware attacks causing data exfiltration. Why is this important, and why is it so important to us and to our endpoint security approach? Because you can have the best disaster recovery strategy when technology like endpoint security fails and a number of files have been encrypted in the endpoint prior to the endpoint security solution being able to act, or the endpoint security solution needed to revert those files or get those files back out of a journaling, out of a backup strategy. But still, if there was data exfiltration prior to the encryption of data, that exfiltration and the result of that exfiltration, and depending on the importance of that data, will be used as part of the ransom. So if technology fails, if the antivirus fails, if the execution technology fails within the antivirus or the next generation antivirus, and if ultimately the backup strategy is there, it still does not solve exfiltration. You have your data back internally, but the data will be somewhere else, and that will be part of strategy. So that kills the backup strategy, the disaster recovery strategy, and stresses how we need, and that's what we believe, to go back to the pre-execution stage and to address the encryption actions and the ransomware execution before it even has a chance to start causing any damage. More on that in a minute.
Yeah, we had just an interesting, I guess, story. These attacks happen all the time. A lot of them don't reach the media because they're private companies. They don't want to go public with it because they, in a lot of cases, they feel embarrassed or ashamed, even though it's not their fault. I don't blame the victims, and we shouldn't blame victims, especially because these attackers are so sophisticated. But a couple weeks ago, Vertex was approached by a large medical interest in the Orlando area headquarter, but they're global, who was attacked with the ransomware situation. What's interesting about that one is the customer decided they would kind of rebuild from some off-net backups they had, and they wouldn't pay ransom. But then the attackers said they'd already exfiltrated all their patient data, and they hit them, instead of a ransom attack, they hit them with an exfiltration kind of public attack where they were going to publish their patient data online. And that was the reason that the practice ended up paying insurance. So exfiltration attacks, especially in areas where there's PII or legal information or compromising info or secret info, whatever, trade secrets, you name it, that is actually a critical issue. I mean, if it's a school district and they're going to publish student data that's beyond enrollment, maybe their grades, health records, who knows what, a lot of times that threat of extortion is dangerous. So yeah, exfiltration is rising from what we're seeing.
And what that strategy and what that shows is also that exfiltration alone can have the layered security approach at risk, right? Because you think, well, I'm going to have an antivirus, then I'm going to have some sort of advanced security at the endpoints, and layer that or layer a stack of technology that addresses hacking operations or attacks as they unfold, and they've got to stop them at some point, even if they are fundamentally unknown in the infrastructure. And if all else fails, I'm going to have a disaster recovery strategy. Well, exfiltration has an impact on this whole flow. And that's why the fact that 70% of the ransomware attacks imply exfiltration is so critical and so important. About alert fatigue, also an important topic and the topic of the day, for so to speak. Organizations without security automation double the costs or almost double the costs from a breach. That is very important. We are going to place in the industry where the increased visibility of advanced security, when we start talking about telemetry, endpoint data, network data correlation, if that correlation is not tied to any sort of automation that assists in fixing the problem that the correlation can expose, so to speak, we're going to have a problem. Because and that ties into what we see with 80% of cybersecurity admins struggling with a barrage of security alerts. So you have a lot of visibility, you have a lot of data, you have a lot of alerts or a lot of triggers, but you need someone to interpret them, or you need that someone or that team to be assisted by a level of automation that ensures that triage and stops the barrage of security alerts. That is critical, and solutions that are not designed for that, or that are strictly designed to assist with the triage work of a cybersecurity specialist, wherever that exists, are falling short of, in most cases, of the level of automation that is necessary to fundamentally address the problem with a posture that is adequate. And that ties also into 70% of cybersecurity professionals claiming their organization is impacted by a skill shortage in the cybersecurity field. So are we vendors absorbing all that talent? Well, from our perspective, we should, because we should power our endpoint security delivery, that agent that we deploy to the endpoints and the services that we tie to it. We should absorb that talent and deliver those services as if they were product features. Replace solutions and administration panels that have the cybersecurity expert in mind. Keep the cybersecurity experts on our end and have them powering services that are delivered as features. The service as feature concept, it's something that is very dear to us and that you'll find very present in the way we do endpoint security, and specifically endpoint detection response. And sure enough, 3.5 million jobs are the 2021 number for absolute number, average, or approximately, for the skills shortage in cybersecurity, which is really worrying. Last but not least, in the stats that I wanted to review with you, complexity and accumulation of agents. This absolute report on resilience, which are numbers for 2020, brought or exposed the fact that 10.2 is the average number of agents deployed in corporate devices just to ensure security features. So there's an average of 10.2 software components just to ensure security in corporate managed devices. So consolidation of the security stack, the feature set of the security solution in single agent architectures is paramount to solving this problem. And this problem is a problem on one side of points of failure. If you have 10.2 agents or 10 agents or even 5 agents, you have 5 points of failure and 5 upgrade cycles to manage, as automated as they can be. Something always goes wrong. At some point, you have a number of devices that are going to report some sort of error, even if it's just a reinstallation routine. It's a maintenance cycle, and also the footprint and the performance impact on the managed endpoints. And all of you, as I will, recognize that 10.2 agents on average just to ensure security. You think, well, what about to ensure productivity or what the devices are actually used for. So this is definitely a challenge and a problem to solve. And the IBM report that this IBM report on data breaches states very clearly that complexity alone in endpoint protection platform solutions by itself creates risk, which is something we see and talking to our partners, delivering our solutions, assisting with implementing. It's something that we see we are solving and we are addressing with the way we built and we built our endpoint security platform and the philosophy that we put into, like I mentioned, delivering more service than features and transforming security features in the endpoint as or delivering them as services and making them service as features. So why is endpoint security still struggling with ransomware? Like I mentioned, I start drilling down to a sort of blue pill, red pill moment where we identify the details that we think matter when we review the details, and we want to have our internal teams and our analysts looking at specific circumstances that we see and come from our threat hunting analysis and looking at wider facts and lessons learned from these more global scale ransomware attacks. We believe these are key points, and those are details that matter when looking, evaluating, and implementing endpoint security, not only as a specific solution A or B, but as a practice. The first one derives from what we're just seeing about the agents, about the 10-2 average agents. It's essential to have a single agent architecture. The more consolidated the architecture is, the more secure the environment is, because we're eliminating points of failure, we're eliminating performance impact, but we're also eliminating footprint and management overhead. And you will need this consolidation and this performance to be there and the level of security to be maintained by not having points of failure and management overhead the moment ransomware hits. The other point is the real-time visibility on deployed agents. We still, when we do comparative analysis, look at the market, and we see in our market, we see 28 different direct competitors that we consider to be direct competitors. And we still look at the landscape of how the agents, the competitor agents are deployed and how, what is the standard in endpoint security. And we still find vendors that have no real-time visibility available. I mean, the agents are collecting data. There's always in the endpoint detection and response approach, a level of data collected from endpoints, the possibility to, of course, we're talking mostly about cloud-based solutions, the possibility from anywhere to any managed endpoint to introduce configuration changes, but the visibility is not always there real time. The fact that real-time visibility exists, we believe it's paramount to be able to have an adequate strategy to deal with ransomware. OS platforms, the OT, the IoT, the industrial use case are still very important to us. And that's what leads us to have legacy coverage. We cover operating systems as legacy as Windows XP and Windows 2003. I cannot stress enough, or I cannot tell you how many times we saw attacks, not only ransomware, but other sorts of attacks that use these blind spots that derive from endpoint security solutions not having coverage for these operating systems. And these operating systems are still much in use in, for example, industrial platforms, in the OT use case, in the OT devices, and you cannot simply upgrade the operating system without upgrading the machinery. It's simply not possible. These are systems that represented a long-term investment, and you either coverage or you either have coverage with endpoint security with an agent and with an equivalent level of visibility, advanced visibility over this kind of devices, or you just going to assume you have a blind spot, and there's some risk assumption around that, and that could make all the difference in a ransomware attack and in other types of attack. Additional protection layers integrated. This goes with the real-time visibility, but above all, with the single agent architectures. how many layers in the stack can you include within that single agent? And how flexible is your possibility to customize a set of security layers? So our flexibility in this case is very interesting. We have a combination of base product that can be a next generation antivirus, can be an EDR platform and its associated services that can run alongside a third-party antivirus, or the combination of antivirus and endpoint detection response, and then customize a set of what we call modules that include advanced reporting and analytics visibility, that may include a patch management functionality, a full encryption functionality, and integration with a third-party CM, and all of these can be customized and delivered from that single agent and from a single management environment, which is our unified security platform. The two last ones are certainly the most important ones, and we'll be focusing a bit on those today. Can zero trust application execution be implemented? That is, can you control, manage, and secure devices by not allowing yet unknown, unseen, unsanctioned executables or libraries to be run without them being approved? And that approval means that before those binaries are executed, they are sanctioned to run based on an assessment that is performed outside of the endpoint and without the endpoint, the managed endpoint that is, needing to actually execute them live. That's when we start hearing about, and you've heard about this possibility, I'm sure, in different ways. We start talking about sandboxing, AI, start talking about machine learning. But the thing is, are we delivering those technologies? Are we delivering in that assessment in a way that it can be manageable from an administration point of view, or are we summoning the administrator to take decisions? We are doing the former. So we make endpoint security, zero trust application execution possible by delivering this assessment for every unsanctioned, new, uncategorized application as a service. Typically in minutes, we will be able to determine if that file should be allowed to execute because it's confirmed goodware, or if we just generated an alert because we found brand new malware. But the thing is, we never allowed it to run in the first place because we suspended its execution. And that's the whole idea. And then how is the weaponization of goodware dealt with? I've associated this before with threat hunting. And in our view, that's all there is to it. And that's a lot. If we can control application execution successfully, address the file-based vector, and only allow goodware to run in the environment that we protect, what else can happen? Well, goodware can be weaponized. Living off the land attacks, malwareless vector, fileless attacks, all of that shows that we can't rest on making zero trust possible in delivering it as a managed service and just assuming that, yeah, that file was goodware at that point and it's going to be goodware for as long as it stays in the endpoint. We need the other component, and that's why, because we control the execution of the file, or we control the file vector by controlling the execution of unknown applications, that we put so much focus and so much research and development on the threat hunting side of things. And also, we deliver this level of threat hunting without an additional cost. That is, without a threat hunting service that is a premium to the license, or even without a managed detection response service, which is also a service option in every other vendor, or the ones that we consider direct competitors, and there's a lot of them out there. There is either a service associated with dealing with the weaponization of goodware, or nothing at all. So because we've been able to control application execution, deliver the control of the unknown, so to speak, in executing files, we have the bandwidth to dedicate, and that's where we're putting all our focus these days on the threat hunting capabilities and in the weaponization of goodware vector. So these, we believe, are the details that matter in implementing an endpoint security strategy, not necessarily product A or B, that is able to deal with ransomware and deal with this kind of attack. Summarizing, and how we get to being able to deliver that zero trust application service or that zero trust perspective. A summary of the pitfalls that I mentioned and how we go from that perspective, which we still believe it's a trust everyone approach, to a real trust no one, zero trust approach. The first pitfall represents the pre-execution stage at which endpoint security solutions work, which is representative of what we keep naming as the traditional antivirus, which has, by the way, nothing traditional about it. It just relies on the vendor knowledge. It's technology that is able to stop threats that are known by the vendor, that are known with 100% security, that have been categorized, they're part of a malware database, or with technologies that are a bit more proactive and are able to detect by heuristic means, by rule sets that are not necessarily based on signatures, or simply by not allowing a URL to be accessed because it's a known source of malware binaries. All of these technologies, like I mentioned, we tend to associate with the traditional antivirus. They are very effective technologies. They're very fast. If we already know something to be a threat, or if we already know with an heuristic method that that is a variation of a threat we have categorized, it's really fast, easy, no impact, no overhead to just block it. But it has an issue, is that if we're seeing something advanced and fundamentally new, it's not going to work. We're going to have to rely on another layer, which I named vendor technology. So, and I mentioned it before, we start hearing about more advanced technology, next gen, that is able to do sandbox execution, that's able to, as an operation unfolds, do advanced behavior analysis based on machine learning techniques, based on AI, all sorts of technology. And that's where we start hearing about distinguishing baseline good actions or good files from bad or potentially bad actions. So there's at some point with a stack of technology that can vary from vendor to vendor, an anomalous behavior detected, and the threat is stopped on its tracks at that point. That means the technology worked in regards to being able to stop something that was fundamentally new. This operates at the execution stage. What is the risk to this set of technology? Well, it's not deciding fast enough, to put it simply. If machine learning, AI, or any other technologies, patented or not, that are included in this stack don't decide fast enough, rollbacks are required. And rollbacks, that's why I call it vendor services. It may be a service that works as a feature out of the endpoint security, is included in the endpoint security. It might be something that derives from the actions taken by a managed detection response service, or simply, like I mentioned in the beginning, could be, you could have a really good disaster recovery strategy and the solutions to go with it. But you are going to have to assume a partial loss of information if the services fail, if the disaster recovery strategies fail. But even if it does not, like I mentioned, considering that 70% of the ransomware attacks include data exfiltration, it doesn't matter how good the vendor services will be, there is no vendor service post-execution that will get those files that were exfiltrated to the third-party bad actor back. Those services don't exist in the market. And that's why you might end up after this cycle in the need for or in the need to assume a risk of loss of information, loss of reputation, depending on how important that data was. And well, to put it in other words, you might end up having to pay the ransom. So we believe and this is a cycle that is still a variation of starting by trusting and going down to not trusting what you know is bad, not trusting what your technology determines with its level of sophistication that might not be good or confirms that it's an anomalous behavior, or in the end, you'll need services that might not be directly related with endpoint security to come to rescue. It's a cycle that is for sure not a zero trust cycle. So our answer to that is starting sort of revisiting the pre-execution stage, addressing threats or addressing the possibility of threats before unknown applications execute. That's what the Zero Trust Application Service is about, distinguishing goodware from malware by classifying applications before they have a chance to execute. And like I mentioned, after assuming that we do a good job, after we allow applications to run, what can happen in an environment where only goodware is allowed to run? Well, a lot can happen. Goodware can and is weaponized every day in attacks that leverage operating system components, leverage productivity tools, or even that do not imply malware or files at all. We address that with execution monitoring, with the baselines and the way we do threat hunting. I'm gonna summarize what our approach is on that in a couple minutes.
Yeah, that's the concept that hackers have of living off the land, right? Where they're using built-in apps and components that are already running on the system to turn against you and using your own attack. And so, PowerShell is the primary example of one of those tools. So the monitoring is critical for that reason.
Absolutely. So it's answering the question, well, if we only allow goodware, and I keep going back to this, but I believe it's a good illustration of what happens. If I did a really good job, and that's saying something, of making it possible to only allow goodware binaries to run in a managed environment, and making it possible in the sense that the WatchGuard is doing that approval, managing that approval process for me. I have to worry about, I have a level of control. You're going to see that. I can introduce exceptions. I have a level of control, but the bulk of that delivery is done by WatchGuard. What happens next? Well, a lot may happen next. At any point, the goodware can be weaponized. And as far as the Zero Trust Application Service goes, it's goodware that it's running, but not as far as the possibilities to weaponize that goodware. So Zero Trust Application Service is based on classifying all running processes. So no application, no process, no library will execute unless it is trusted. And so when we execute applications or execute binaries in endpoints that we protect, they are either allowed to run immediately because they're already known to be good, they're stopped because, like any other antivirus, we already know to be bad, or the classification cycle begins. So all behaviors are verified in real time without needing any approval or without starting any process that implies admin intervention. And 99.98% of all classified applications are classified automatically. This means that the delivery, that suspending of execution for that yet unknown unclassified item, will happen just for typically a matter of minutes. In 0.02% of all the files that are submitted for classification from the endpoints that we protect, we need an analyst involved. This means that we trigger a process with a set of algorithms that in the end cannot decide whether something is good or bad. For that, we need an analyst. But if we need an analyst, of course, the delivery time, the turnaround time can vary. It typically means that you would not want to execute that yet unknown, unclassified binary or executable. To put it simply, it is bad. We're just determining how bad it is, and we're determining the exact nature of the malware components that we are seeing and the damage potential that file can cause. So in only 0.02% of all submissions to the service, which are automated by the agent, we need expert review. And that expert review is also an important component of not only trusting in machine learning, AI, and trusting on all those technologies that, sure enough, they get better the more files they classify, the more circumstance with more correlation, but we always need an analyst component to this. And we have it for anything that, even at the file vector, the system cannot decide, the automated systems cannot decide on. And then the threat hunting. So a different team, a different set of experts, but they are focused on monitoring and building baselines for the environments that we protect that are based on that living off the land vector, on the fileless attack, on profiling users, their relationship, the relationship with users, the devices they use, the applications they run, addressing the lateral movement actions, lateral movement possibilities, compromised credentials, behavior modeling to address malicious employees, or the inside vector, and working off of a data lake that we have for all the endpoints that we protect out of 12 months. So we are not only looking at IOAs that we have already produced. We're not looking at this only from a threat detection perspective. We are constantly developing new hypotheses that we test against the telemetry that we receive from all the endpoints that we protect, and trying to find new vectors, new early stages of an attack. And in case of validated breach, the administrator will get a notification. And I want to highlight validated breach, and I'm going to show you how that comes about in the product console, because again, this is, and to address the alert fatigue, we're not going to trigger an alert just because we triggered on our backend an IOA. We are going to have a method that typically goes through an analyst of verifying that alert against the telemetry that generated it to confirm it. Although we're confirming circumstances that may lead to an attack or the early stages of an attack, those are confirmed, validated, triaged IOAs. They're not simply alerts that come from our backend, from automated signatures, or from automated methods of triggering a detection method. Those are validated, and that's an important an important vehicle to address the alert fatigue and the complexity that that we've seen in numbers in the beginning. So it's about preventing incidents before they happen. There's a set. We saw the pitfalls were related with the stages. Well, or I try to put it that way to make it simple. Pre-execution, what happens, or what technologies can kick in when potentially unwanted or potentially malicious elements were already executed, and last but not least, the post-execution vector, where you can weaponize goodware. Well, the bulk of what we do currently today is in the combination of the reactive technologies. That's why I said, well, we typically associate them with traditional antivirus, but they need to be there, because if we already know something to be malicious, we need a stack of technologies that can prevent you from accessing a website that has a malicious reputation, signatures for known malware, heuristics, blacklist rule sets that are very quick in detecting and not allowing circumstances to happen before you need execution-based endpoint protection technologies to kick in. That's why we insist so much on the combination of antivirus and EDR in a single agent that our WatchGuard EPDR technology represents, and then the zero trust application service. So while with the signatures we address the known bad, with the zero trust application services we control the unknown. Every single new binary not seen, not only on that endpoint, not only on that specific client, but in all the community of endpoints that we have protected with our service will be suspended execution until, like we've seen, typically in minutes, we determine if that file should be allowed to run, or if we, as we often do, find a file that is a variant of something we already know to be malicious, or that is brand new malware corresponding to a brand new backdoor strategy.
Yeah, we had one yesterday, actually, internally at Vertex. We use these technologies ourselves, of course, but we had one yesterday inside of Vertex. We got an alert on, and then the reclassification to kind of goodware happened in about 8 minutes all in. And we got a notification that it was reclassified. It was a DLL that hadn't prior executed on a few boxes, so, or anywhere else, obviously. So this stuff definitely works.
Well, let's illustrate a bit of what would be the result of what we saw just yesterday with this, of going through this cycle. So when we deploy the agent to our endpoints, and we're looking at our EPDR, WatchGuard EPDR console, which is integrated with WatchGuard Cloud, it all starts with deploying that agent, which we have for Windows, Mac OS, Linux, and Android. We're going to add iOS in the first quarter of 2022, but it doesn't matter the association of or the logical association of these devices. We're talking about a cloud-based solution. You just need the agent to be in, although you can manage and apply policies based on your own organizational structure that you define here, or even based on or replicating what you have with your Active Directory. So it's multi-platform, but the multi-platform as in operating system support, but all the management will be done through this panel. So what happens, and let's go straight to the Zero Trust Application Service when we deploy this agent. So this agent will start profiling applications that exist already in execution in the endpoints. And it will start distinguishing trusted programs, which we expect it's even higher. Typically, we're looking at a sandbox environment to be the bulk of what we find, right? Unless we're deploying to a compromised environment, which is, by the way, something we can address as well. Malware, files that we classify as malware, files that we classify as exploit, or potentially unwanted programs. And I'll show you an example, which are programs that are typically installed with user consent, but they have unwanted impact in the network or in the endpoint and performance, a footprint that we can demonstrate and we can block. So that profiling starts as soon as the agent is deployed in the endpoint. And to make things easier, anything that is already deployed to the endpoint prior to the installation of the agent will be assessed without us necessarily at that point, or the agent in this case, stopping anything unknown. So we are assuming, and just assuming for that preventive suspension of execution, that what you have deployed to your endpoints is goodware. But we're going to classify everything. So automatically, the agent is going to query for the reputation of everything that is being executed, but we're not stopping anything unknown at that point, if it already exists in the endpoint. But if we classify one or multiple binaries during this process as malicious, from the moment we classify them, we are going to stop that execution. So we make transitioning to zero trust easier by not just starting to suspend the execution of things that we find in execution already in the environment that we're deploying to. But if the user downloads a file that is a binary, a DLL, an executable, by an external vector, that is from the internet, from another server in the network, through a USB stick, a removable storage USB drive that is connected to the device, then we'll start from that moment, from day one, applying zero trust. We're going to suspend the execution of the binary if it's unknown, and it will allow to run if it's confirmed good, or it will not run, and we will issue a malware alert in that case if we determine it to be malware. So what is the anatomy of a malware alert that we generate under those circumstances? So let's look at an example and to illustrate what Don was just mentioning. So we found a new thread that we classified. We have the hash for that new thread in server 1. We know that it has run. It has exchanged data with other computers. So we are illustrating to show you the forensic capabilities of this solution, a file that has run, because imagine we're in this initial stage where that file existed in the managed endpoint prior to the deployment, and we are just taking it through the cycle, seeing it, what it does, and classifying it based on what we actually saw happening in the endpoint. But this is just stage 1. And this also illustrates that you don't need to immediately go all in on the zero trust perspective, and you don't need to go all in immediately for all points of your network or for all your devices. You can have groups that are going full zero trust, and you have groups that we're still building the baseline for, and we will still be able to stop that brand new malware and generate forensic information in the format that we are going to look at. So 17 minutes and 18 seconds is the dwell time. That is the first action that we saw from this brand new binary, and you can see it's an example of, with double extension, an executable file that was trying to pose as an MP4 video. 17 minutes and 18 seconds from the first action that we saw in the managed endpoint was this binary, to the point that we've issued this malware alert after classifying it as new malware. We can look at the infection source. You can look at the public IP. If there's a vector involved, which is a public IP, we identify it automatically and identify occurrences in other computers. But we also recreate, and this is an illustration also of the level of visibility that we can bring into the forensic information of any given attack. We build the whole set of circumstances chronologically organized of the actions taken by this binary while we were classifying it. And that includes creating registry keys, loading either other libraries, being run by other binaries, summoning other libraries or other executables, and the use of sockets, establishing network connections. And we can even recreate all of that in a timeline. We can go back to the first node. So this one initially started by creating these two registry keys, and we can recreate the whole cycle, stop at any point of all the actions that were taken to the point where we generated the alert. And something that is very interesting and we're told differentiative is not only that we identify the IPs involved, like we saw the sockets open by this application that we considered malicious, we identify not only the IP, in this case public, but each instance, and a port as well. In each instance where we're talking about a public IP, we identify the location. We automatically, as part of the forensic information, we geolocate that IP, as well as identifying any goodware that was involved in this attack, going through the living off the land. At some point, this brand new binary that we classified as malicious leveraged goodware, leveraged explorer.exe, which is fairly common, but we know that it used Chrome in the attack chain. So this is the level of forensics and the data that we can generate for any given attack, which is based on the Zero Trust Application Service, and which is file-based. That is based on this cycle of classification. The other vector I wanted to show you, and the other type of alert, is the one that is related with potentially unwanted programs. Like I mentioned, we have the ability to, this is not malware in the sense that it was software that was installed with user consent, and there are typically EULAs associated with this. We're talking about freeware, we're talking about freemium models. But if we identify circumstances that are suspicious or resource abuse in the managed endpoints, we can stop this potentially unwanted program. We can suspend its execution. Again, the structure is the same. So we immediately knew these actions, or we immediately recognize this potentially unwanted program. So in this case, that was no dwell time. So we had technologies from the antivirus, and that's how we see them working together, that kicked in and assisted the endpoint detection response. In this case, we identify the infection source, and we can illustrate easily, and we would just stop it from an antivirus perspective, without really knowing what this does. But when we bring the EDR visibility and the forensics to the table, now we can identify the number of connections open by this updater in a very short time frame and for a number of distinct public IP addresses. And that's what triggered this known circumstance that we've even incorporated in more reactive technologies. So that means that we already know this potentially unwanted program does that. And we blocked it, to put it simply, with antivirus reactive technologies. But still, because we have the EDR visibility, we can always paint the EDR picture. That's the great advantage in having these features, the antivirus features, the antivirus stack, and the endpoint detection response services combined. Before we illustrate the threat hunting side of things, let me highlight something very important. When we're talking about the feature set, and what we mentioned would be the possibilities within the base product and its associated modules, which is also the anatomy of deploying configuration sets. So we can deploy any configuration set or any aspect of the solution by settings profile definition that has specific recipients. So, and those recipients can be Active Directory, OUs, or containers, or can be our individual definition or filters for our machines. In this case, let's apply it to virtual machines, and we can even combine that with selecting individual computers. So this configuration set will be applied to this scope. So if we want to make distinct configurations regarding how aggressive we are with the zero trust, and there are different possibilities around that we want a policy for the servers, we want another policy for the workstations. We're not ready to go all in, so we're just trying things out and making sure that we go zero trust and start adopting it when we're ready. That's a baseline, obviously, to be built here, and that's why when we deploy the agent, we don't suspend unknown files that were already deployed to the endpoint. But what I want to illustrate is that does not to be an everything or all or nothing perspective. There's flexibility in this for you to be able to control the process and for you to be able to introduce configuration sets and customize the deployment to the security posture you want to reach at. And also, I want to highlight that apart from the advanced protection, so the technologies that are associated with the behavior of the EDR, the anti-exploit, even some settings to control privacy, in as much as this works with telemetry that we correlate and consolidate from the managed endpoints, you will not be missing out on any feature that is expected of an antivirus. And that's not only reactive signature-based technologies or web browsing antivirus, URL reputation, but also firewall. An endpoint firewall is there in case, and it's completely optional, obviously, in case you need one. Device control is there, not only for USBs, but for all these types of devices with an allow list that you can configure. And even you have web access control, which is category-based, more of a productivity feature where you can enable web access policies to work during specific scheduled and block specific categories and introduce allow lists and deny lists. So we're talking about an endpoint detection response platform, but we're talking about an endpoint detection response platform that, because it's consolidated within a single agent with a next generation antivirus, will not have you miss out on features that are expected of the antivirus layer. So you can look at web access. We have web access monitoring. This is more from a productivity perspective, but it's all endpoint data, and it's all layers or components of the endpoint stack that are necessary for adequate protection.
If I could, let me chime in for a second there and just make two kind of quick comments. One being, I do 100% agree with you, of course, about consolidating agents and reducing agent sprawl, because it adds complexity, points of failure, and more kind of alert fatigue and all that. I get that 100%. However, just to be clear, you can keep your current kind of commodity AV if you need to because of contract terms and that kind of thing for a period of time, and just layer on top of it our advanced capabilities. That's possible. You can do that. And then additionally, a lot of the things that Rui has been showing, it looks like a lot there, of course, and I know it is, but realize most of it is very automated, and it's doing it for you. But you have evidence to support your monitoring this stuff, and also you've got forensic data and telemetry data to look into a potential attack or look into potential nefarious actions. Lastly, we do have, for folks that are looking to take the next step forward in their own internal operations in cybersecurity and want to deploy SIEM or SOAR or something like that, we do have the ability to publish this data via a SIEM feed and ingest that data into your SIEM platform for correlation upstream in your SIEM. So all that's there too. But if you don't want to do a SIEM, and that's too, because it can be expensive to manage and maintain and license and all that, I feel like this is definitely at the level where it's SIEM-like. If you're monitoring it and you're getting the analytics and telemetry data, you're very close because a lot of the correlation is being done for you, the threat hunting is being done for you, and a lot of that is what SIEM does. So keep in mind those kinds of things when you're evaluating your cybersecurity stack in your network.
Thanks, Don. And we'll finish with the threat hunting indicators of attack. So what we've seen so far illustrates our point with 50% of what our strategy in endpoint detection response pivots on, the dealing with the unknown, making it possible, in essence, to implement real zero trust at the endpoint. And then we talked about the weaponization of goodware. What happens in that environment that we protect with the zero trust application service where only goodware is running? Well, weaponization of goodware. And this funnel illustrates also a point that I've insisted on the presentation, and goes through a combination of how we deal with alert fatigue and how we introduce automation in all of this. And automation not being only automation in the sense that we have automated means to classify files or to generate IOAs that we've already developed, but also in the zero trust application service space to have analysts looking at yet unknown unclassified files that the automated system cannot decide on, and on the threat hunting service, having indicators of attack being issued that are validated by our experts. So from a total of over 12,000 events in this time period in a month, 1,200 indicators were generated, unvalidated indicators that could easily be presented as we find in other solutions, and those that are associated, well, many solutions that are associated with the numbers we see on frustration with complexity and alert fatigue could easily generate alerts. But we are only generating 46 indicators of attack. We're only generating 46 reports for entirely validated indicators of attack. And these had analyst review to be issued. So we're going to be looking at circumstances that have nothing to do with files, that will introduce recommendations or even actions for non-file related attacks. And we're going to look at them in the context of the MITRE attack matrix. So we're going to identify each one of those validated attacks and put them in their right spot in the tactics and techniques represented by the MITRE attack matrix. Let's just look at a couple examples. So we see execution, for example, a report on the execution of obfuscated command line parameters using CMD. And we are recreating and issuing the telemetry of what we're seeing here. Here are the command line and the obfuscation technique that was utilized, exposed in this CMD agent, and related with the parent path, which is in fact network location, the process ID, the MITRE technique mapping and the explanation, and recommendation. So fixing this or addressing the possibility of running this specific obfuscated command line parameters implies actions that need to be taken outside of the EDR. And that's why we issue recommendations. Block CMD program on the attack computer, scan the computer, change computer credentials. So preventive features that imply actions or improvements in the security posture that need to be addressed outside the specific action that can be taken by the EDR component. Another one, and I'll finalize with this one, is an example where actually an action was taken. Credentials compromised after brute force attacks on RDP. So we issued a source IP, the action that was taken, but the action that was taken in this case, although we have a set of recommendations, if the automated containment is not configured, we actually have a containment mode that can be configured off the settings that establishes an automated threshold. You don't need to configure how many times you want to, how many times you want to set for the containment mode to be activated if a brute force attack is done on RDP. We control that. You just need to configure where you want it, for which endpoints or servers you want it. And in this case, we're not only issuing a confirmed IOA, we are issuing it, informing or adding in the report that the computer is, in this case, a server, in is RDP attack containment mode. So not only we issued the alert, confirmed the brute force attack, but we've prevented RDP connections to the affected computer as a containment measure. So we can issue both IOAs, confirmed IOAs that react depending on the type of attack automatically to the circumstances that are raised by the IOA, or we can issue the detailed report with the details of why we validated that IOA and with recommendations to introduce changes in the network, changes in the policies in the endpoints to prevent this early stage of the attack in future circumstances. And that's all for today.
Yeah, appreciate that, Rui. I know we're at time for everybody. Appreciate everybody's attendance today. We will send a copy of this recording to everyone that registered, so you can share that and watch it offline as well. Also wanted to make sure that with all the information presented, I know that's going to kind of stick around and you might think about it some and come up with some questions later. Wanted to offer that, we're available to you to answer questions one-on-one, directly, do another demo or do a deep dive. Or if you want to do a tech session and talk about how this might integrate with your other stuff, glad to do that as well. Or present it to a broader group privately in your company. So all those things are on the table. Let us know if we can help in any way. Appreciate you joining us. Happy holidays to everybody. Hope you have a great week and a weekend ahead. And we'll stick around for a couple of minutes to answer any last questions. Feel free to use the Q&A or chat panels. We'll monitor those. Otherwise, have a great day.